There is a region on Mars, roughly the size of Australia, that rises high above the surface of the planet. 3 of the largest volcanoes in the solar system line up to guard its western flank. To the east, a vast canyon, 6 to 7 times deeper than the Grand Canyon, cuts into the barren Martian plain. This strange region, once so baffling to scientists, recalls the planet's violent past. A time long ago when the planet's core erupted, pushing molten rock to the surface. It's part of a larger story, a planetary tragedy, in which Mars began its descent into the cold, dry, and lifeless state that we see today. We are now scouring its surprisingly complex surface for clues to the events that long ago doomed the red planet Mars. Since the early 1960s, we've tried 46 times to send spacecraft to Mars, across the 55 million kilometers of its closest approach to Earth. Over half failed at launch or upon arrival. The rest flew around the planet, snapping pictures, recording data. Or they landed to test its soil and rocks, and crawl around its canyons and craters. These probes may one day pave the way for human explorers, who will dig deeper still in search of answers to our most pressing question. Did Mars, at some point long ago, develop far enough for life to arise? If so, does anything still live within Mars' dusty plains, beneath its ice caps, or somewhere underground? Mars does not give up its secrets easily. Over the years, that has led observers on this planet to jump to all sorts of conclusions. In the year 1877, the Italian astronomer Giovanni Schiaparelli noted markings on Mars' surface, a latticework of lines. He called them canali in Italian, meaning channels in English. Schiaparelli began to sketch them and name them, connecting them in a vast global network. Over a 15-year period, beginning in 1894, the American astronomer Percival Lowell closely examined these features. He saw a remarkable drama unfolding on our neighboring planet. In his view, Schiaparelli's channels were artificial canals designed perhaps to carry melting snow from the poles to the dry interior. After all, on Earth, the Suez Canal had been open since 1869. Construction on the Panama Canal had just gotten underway. The Martian canals, Lowell surmised, had been built by a sophisticated society confronting an environmental catastrophe on the grandest of scales. Its inhabitants faced an urgent choice: move water across vast arid regions or perish on an increasingly dry planet. In a series of 3 best-selling books, Lowell took his case to the public. The public responded, with some ideas of their own. With the means to remake an entire planet, perhaps these Martians were more advanced than humans. Some of us began offering schemes for making contact. Giant mirrors to flash greetings, light beams, mental telepathy. Lowell's vision fell by the wayside in 1964. The Mariner 4 spacecraft flew by Mars and got a good look. What it saw looked more like the Moon than the Earth. 3 more mariners followed. These missions documented a heavily cratered landscape, pocked with huge dormant volcanoes, and cut with the deepest and longest canyon in the solar system. They saw no traces of life, present or past. Then, in the mid-1970s, 2 lander-orbiter robot teams, named Viking, went in for an even closer look. The landers tested the soil for the chemical residues of life. All the evidence from Viking told us Mars is dead and extremely harsh. The mission recorded Martian surface temperatures from -17 degrees Celsius down to -107. We now know it can get even colder than that at the poles. The atmosphere is 95% carbon dioxide, with only traces of oxygen. And it's extremely thin, with less than 1% of the surface pressure of Earth's atmosphere. And it's bone dry. In fact, the Sahara Desert is a rainforest compared to Mars, where water vapor is a trace gas in the atmosphere. On Earth, impact craters erode over time from wind and water, and even volcanic activity. On Mars, they can linger for billions of years. Earth's surface is shaped and reshaped by the horizontal movement of plates that make up its crust, driven by heat welling up from the planet's hot interior. At half the width and only 11% the mass of Earth, Mars doesn't generate enough heat to support wide-scale plate tectonics. Nor does it have the gravity to hold a thick atmosphere needed to store enough heat at the surface to allow liquid water to flow. Nonetheless, some areas that looked to Viking-era scientists like craters and volcanic areas were later shown to be riverbeds, lake bottoms, and ocean shorelines. If water once flowed on Mars' surface, where did it all go? This was the scene at NASA's Jet Propulsion Lab in 2004. The twin rovers Spirit and Opportunity had just bounced down on the red planet. When the excitement died down, the rovers were set off on one of the most remarkable journeys in the history of planetary exploration. Opportunity had come to rest in a small crater near the equator, at a spot called Meridiani Planum. Here in plain view, on a nearby crater wall, its camera revealed exposed bedrock, the first ever seen on Mars. Not far away, the rover found layered rocks on the face of a cliff. On Earth, they typically form as sedimentary layers at the bottom of oceans. And at every turn, Opportunity rolled across tiny, smooth, round pellets. They became known as blueberries because they appeared purplish-brown against Mars' rust-colored surface. Initially thought to be volcanic in origin, they turned out to be iron-rich spherules of the type that form within cavities in the mud at the bottom of an ocean. Drilling into rocks, the rover inserted a spectrometer to read the mineral content. The readings showed significant amounts of sulfate salt, a tracer for standing water. That wasn't all. Spirit's broken wheel dragging behind it exposed soils saturated in salt. Clearly, there was once water on Mars' surface. But how long ago? And if there's anything left, where would you find it? One possible answer: the North Pole. From orbit, this region seemed to be covered in frozen CO2, what we call dry ice. But was there water ice below the surface? Enter Phoenix, a lander that touched down near the North Pole in early 2008. Radar readings from orbit, taken by the Mars Express mission, hinted at the presence of ice just below the surface. The Phoenix lander's descent thrusters blew away the top layer of soil, allowing its camera to snap pictures of what looked like ice. Scientists instructed the robot to conduct a simple experiment. Reach out and dig a trench. Then watch what happens. As expected, clumps of white stuff appeared. A couple of days later, it was gone. Vaporized. That means it can't be salt or frozen CO2, which is stable in the cold, dry temperatures of the Martian pole. So it had to be water, the first ever directly seen on Mars. There are indications that the North Pole was actually warm enough in the recent past for water ice to become liquid. The Mars Reconnaissance Orbiter, or MRO, used radar pulses to peer beneath the surface of the ice cap. These data revealed that the ice, just over a mile thick, formed in a succession of layers as the climate alternated between warm and cold. Our planet avoids mood swings like this, in part because its spin is stabilized by a massive moon. Mars' spin is not, so it can really wobble, with the pole tilting toward the sun for long periods. New observations by the MRO spacecraft show that these wobbles can lead to dramatic releases of CO2 and warming periods due to an increase in the greenhouse effect. The ice now detected below Mars' surface is a remnant of a much earlier time. The thinking is that not long after its birth, the planet's molten interior would have spewed out enough gas to form an atmosphere. Carbon dioxide and water vapor began to trap heat from sunlight. Temperatures rose high enough to allow liquid water to flow on the surface, creating myriad rivers, ponds, lakes, and oceans. Evidence of this thicker atmosphere landed literally in Opportunity's backyard. The rover spied a strange bluish rock, a nickel-iron meteorite named Block Island. Streaking through a thin atmosphere, this massive chunk of metal should have been obliterated on contact. Instead, its fall was likely slowed and its impact softened by a much thicker atmosphere. What then caused the atmosphere and the water to disappear, and the planet to grow cold and dry? The answer comes from data recorded by the Mars Global Surveyor just after it went into orbit in 1997. Its instruments detected the presence of a weak magnetic field emanating from the planet, a reading that scientists eagerly compared to that of Earth. Our planet's magnetic field is generated by molten rock deep in its core that rises and falls into a vast region below the outer crust called the mantle. The rising and sinking motion within, combined with the spinning motion of the planet, generates a strong magnetic field. You can trace this field back to Earth's early years, when large amounts of heavy elements such as iron sank into its core. Radioactive decay began to generate heat, and the planet's mass is large enough to hold it in. Earth's magnetic field extends far enough out into space to deflect the wind of high-energy solar particles. Without a similar electromagnetic deflector shield on Mars, solar radiation lashed the planet, gradually stripping it of its atmosphere. What water Mars had would have vaporized into space or frozen underground. However, there is evidence that at one time, Mars did have a robust magnetic field. Rocks in some of the older craters bear a strong imprint of this field, while newer craters indicate a much weaker field. What happened to it? The answer lies deep in Mars' past, in events so powerful they are still written on the landscape. This is a simple elevation map of Mars' surface from data gathered by the Mars Odyssey spacecraft. The South Pole, colored in red and orange, is piled high with ice. Moving off these southern highlands, we make our way north. The landscape is pocked with craters. The largest and oldest ones have faded, their edges softened by wind-blown dust. Moving up along the equator, we pass into a region called Tharsis, based on a biblical name for the western edge of the known world. On the edge of this vast high-altitude plateau is a series of enormous volcanoes. Ascraeus Mons, 18 kilometers high. Arsia Mons, 16 kilometers. Pavonis Mons, 14 kilometers. Just beyond is the largest volcano in our solar system, Olympus Mons, 25 kilometers in elevation. The thinking is that the Tharsis region bulged out when a giant dome of magma pushed up from the planet's core. The volcanoes grew large because Mars lacks the constant shifting of crustal plates that on Earth leads to chains of smaller volcanoes, like the Hawaiian Islands. Just to the east is the great Valles Marineris, named for the Mariner 9 mission that found this vast gash in the Martian landscape. It's about 4,000 kilometers long and up to 200 kilometers wide. On Earth, Valles Marineris would stretch from Los Angeles all the way to the Atlantic coast. If you went to Valles Marineris, you'd see dust devils sweeping along the plains above it, and dust blowing up the canyon walls. Here's a realistic rendering of data captured by spacecraft. Giant landslides have caused the walls to slump off and pile onto the valley floor. Feeding into the valley, a maze of side channels. Scientists think these and other tributary features were formed when underground water flowed into the main basin and the land above collapsed. Wider parts of the canyon are regarded as possible landing sites for a manned mission. They offer flat surfaces and possible access to liquid water that may remain below the surface. The theory is that Valles Marineris formed when the planet began to cool. Its sides were pulled apart as the Tharsis Plateau just to the west began to rise up. That chain of events is now being linked to a much larger planetary event. What one scientist called the defining moment in Mars history. Travel north down the slopes of Mars' great volcanoes. The elevation drops as we move across what appears to be an immense ocean, colored here in blue. With this so-called Borealis Basin in the north and the high elevations of the south, Mars is a lopsided planet. In fact, there is a difference of about 30 kilometers in the thickness of the crust in these two regions. Here's the reason. Early on, when the solar system was young, Mars was hit by at least 15 large asteroids. Scientists have linked these events to a time around 3.9 billion years ago, known as the Late Heavy Bombardment, when rock samples from the Apollo landings show that our own moon was seriously pummeled. One theory holds that these impacts heated the outer subsurface layer of the planet, Mars' mantle. That prevented molten rock in its core from rising up and caused the crust to thicken. This had the effect of shutting off Mars' magnetic field, exposing the planet to damaging solar winds, and over time, turning it into a wasteland. There are other theories that explain the disappearance of Mars' magnetic field and its atmosphere. What's certain is that at some point early in its history, the red planet grew increasingly desolate. The Martian landscape we see today is replete with coded signals from these early times: ancient riverbeds and lake bottoms, floodplains, and volcanic cones, as well as the battering it received from impacts. But is Mars a dead world? Maybe, maybe not. An infrared telescope on Hawaii's Mauna Kea volcano was trained on Mars over several years. Astronomers used a spectrometer to split the light into its individual wavelengths to identify chemical fingerprints in the atmosphere. They found the signature of methane gas in amounts that change from place to place. Because methane should disappear quickly in Mars' atmosphere, there must be some source that constantly replenishes it. That source could amount to nothing more than the chemical reactions in Mars' crust. Or it could be biological in nature. Perhaps microbes alive and well in heated pools underground. So far, neither the satellites flying over Mars nor the robots on the ground have turned up anything close to clear proof of life. It may take the searching eyes, flexible minds, and nimble fingers of human explorers to find that buried treasure, if it exists. In the meantime, we are finding that even if Mars is dead, it's certainly not dull. Mars has nowhere near the dynamism of Earth. With its oceans, atmosphere, volcanism, and shifting continents. But it does do some fascinating things. If you take an atmosphere, however tenuous, add heat from the sun, you get the renowned dust devils of Mars. With no trees to hold the soil down, landslides are common. The Mars Reconnaissance Orbiter has returned images showing that Mars is actively remaking its surface. Not in canals built by the Martian engineers of Percival Lowell's imagination, but in sand dunes shaped by the wind, and in landscapes molded by a gradually changing climate. Some scientists have even turned up hints of low-level plate tectonics. Whether or not we ever find life forms on Mars, we can still marvel at the beauty of our neighboring planet. Its surface subtly sculpted over eons of time, on a world that never was.